Hello everybody, today we're going to look at solving a quadratic by graphing. So we've been looking at how to make an equation, look at what the vertex is, axis of symmetry, how can you make a graph. Now we're actually trying to solve. So solving an equation means for looking for what are called the zeros or solutions or roots to the equation. And what that looks like on your picture, it's any place that your curve crosses the x-axis. So this horizontal line going across, if you have a parabola that crosses that x-axis, we want to know where it crosses. So whatever those two spots are, or maybe there's one spot, or maybe there are no spots, we need to find those. And those spots are called solutions, roots, and zeros. So again, we're looking for our equation, y equals ax squared plus bx plus c, but now we're going to have that equation be equal to 0. So we're going to try to find those spots. The ways that we're going to be able to find these solutions are by graphing, which is what we're going to do today. We're going to solve by factoring. We can solve by something called the square root method. We can solve by something called complete the square, and then the last thing we look at in chapter 9 is solving by the quadratic formula. Today, we're going to try graphing. So if you could write this equation down, x squared plus 6x plus 8 equals 0, make yourself a grid, and what we're going to try to do is run through the list of things that we've been working on this whole chapter. Let's start with the axis of symmetry. Now remember, negative b over 2a. Your b number is 6, so we want negative 6 over 2 times, and your a number is the number in the front, ours is 1. Negative 6 over 2, negative 3. That's the first piece to your vertex, negative 3. You can also dot in your dotted line at x equals negative 3. We could answer the y-intercept question right away. Y-intercept, remember, is the c number sitting in the very back of your equation. Our number happens to be 8. 0, 8 is the y-intercept, which means your curve crosses way up here. And there's also going to be a symmetric spot on the other side of that. So remember, you could always count 1, 2, 3 to the line and 1, 2, 3 on the other side. So there's 2 spots that you could use for your graph if you want. All right, we need to get the other piece to the vertex. So now is when we plug in negative 3. We're going to go back to the original. We're going to take out every x. We're going to plug in negative 3, square that, plus 6 times, take out x, plug in negative 3, and then we have to plus 8. Negative 3 squared means negative times negative, positive 9. 6 times negative 3 is negative 18, plus 8. 9 subtract 18 is negative 9. Negative 9 plus 8 is negative 1. Our vertex is at negative 3, comma, negative 1. And we can put that on our graph. This curve faces up. Since our leading number in the front was positive 1, this curve faces up. So it's going to be someplace starting at 0 going up to these 2 points. We're looking for where it's going to cross. So now what we're going to do is make a table, and then this table should help us find some spots. Remember, our vertex can go right in the middle, negative 3, comma, negative 1. And then we can pick some numbers on the other sides. So negative 3, negative 2, negative 1, and then negative 4, negative 5. Remember, these will match. So we only have to really find 2 numbers. If we want to try negative 2, let's put that into the very original equation. I'll switch to a different color. So we're going to take negative 2 squared plus 6 times negative 2, and and then we have to plus 8. Negative 2 times negative 2 is 4, plus 6 times negative 2 is negative 12, subtract 8. 4 plus negative 12, and negative 8 minus 8, negative 16. I have a sign wrong on here. This is actually positive 8, so plus 8, negative 8, plus 8, 0. There we go. That makes more sense. Okay, so the point that we tried was negative 2. Negative 2 matches with 0. Negative 4 matches with 0. I can put those on my graph. Negative 2, 0, negative 4, 0. Those are actually the two spots right there that we're looking for, so we don't even have to finish the rest of our table. We can go ahead and make our curve, and remember the spots that we're looking for that cross the x-axis are right here. It's those two dots. So your two solutions are those two x numbers that you came up with, negative 4 and negative 2. That's what we're looking for when we graph. All right, let's try another one. Try not to make a mistake on this one for you. All right, so here's your equation, x squared plus 4x plus 4. Let's start with the axis of symmetry. Negative b over 2a. Your b number is 4. Negative 4 over 2 times your a number is 1. Negative 4 over 2, negative 4. Your axis of symmetry is x equals negative 2. You can draw in that dotted line. Your y-intercept, let's answer that right away. That's your number in the back, 0, 4. Right there. Our vertex is negative 2, plug it in. So now we have to take the number negative 2 and plug that in up in the original. Negative 2 squared plus 4 times negative 2 plus 4. Negative 2 squared is positive 4. 4 times negative 2, negative 8 plus 4. 4 subtract 8 is negative 4. Negative 4 plus 4, 0. Your vertex is located at negative 2, 0. Put that on your graph. Now we can make our table. We'll put negative 2, 0 in the middle. And then we need two other points. Negative 1, 0, negative 3, negative 4. Now remember, the 0 number we've already got, that's actually the y-intercept, so we can fill that in, 0, 4, and then it has a matching right there, negative 4, 4. You can go ahead and put that on your graph. So we only have to find one other point in our table. Let's try negative 1. Negative 1 squared plus 4 times negative 1 plus 4. 1, subtract 4, plus 4. 1 minus 4 is negative 3. Negative 3 plus 4 is 1. So negative 1, 1, negative 3, 1, those match. And we can plot those. You have enough to make your curve. Now, do you notice that your curve does not cross the axis in two places? It only crosses in one place, which is fine. Your answers will either be two places, like we had here. Your curve could cross twice. In this case, your curve only crosses once, so there is only one answer, and that spot is negative 2. This last example I'm going to show you is one where the curve is not going to cross at all. So this is the third sample. All right, axis of symmetry, negative b over 2a. negative 4 over 2 times 2. Negative 4 over 4, negative 1. Axis of symmetry, x equals negative 1. Put that number right here and we can fill it in. We're going to take out every x, we'll put in a negative 1. 2 times negative 1 squared plus 4 times negative 1 plus 3. Negative 1 squared is 1, so we have 2 times 1 plus 4 times negative 1 plus 3. 2, subtract 4 plus 3. 2 minus 4 is negative 2. Negative 2 plus 3 is 1. Your vertex is located at negative 1, 1. Your y-intercept, number in the back is a positive 3. So your y-intercept is located at 0, 3. And remember, it has a matching point on the other side. And this curve faces up. This front number is a positive 2, which means your curve goes up. So if I draw a picture of a curve going up, and this is my vertex, that's the lowest point, your curve does not even touch the x-axis. It's above the x-axis and getting higher, which means there are no intercepts, so we do not even need to make a table. There are no answers to this one. So when they ask you how many x-intercepts do you have, none for this case. So when you're drawing your pictures, you're either going to have 2 solutions, 1 solution, or no solutions. And this last one is your example with no solution. Okay, so for your practice on page 645, I only assigned 6 questions for you to draw. 2 of them will come out with 2 solutions. I believe a couple of them will come out as no solutions, and a couple of them will come out with 1 solution. So that'll give you practice of exactly the 3 same that we did right here on the board. All right, good luck, and we'll see you next time.